We'll proceed in parameterization in calculus, especially in 3D and Jacobian. Parameterization in calculus. Parameterization in calculus, where in xy plane, if I have independent component as x, y, z, whatever, that independent component is again made dependent upon other components. That is parameterization. X equal to some function over u v, y equal to some function over u v. If we are talking about 3D, if we are talking about three dimension, then we have integration of a surface along xy plane. If I have a surface and I want integration along xy plane, indirectly I am talking about calculating the volume of a surface. So if I have xy plane, x-axis, y-axis, z-axis and xy plane, if I have a surface and if I integrate this surface along xy plane, I am calculating the volume underneath the surface that is hitting the xy plane full. It will be volume. That is fxy dxy plane, dA or dx dy in Cartesian coordinate system. Okay, if that is the case, then sometime we start feeling that it is difficult. The way we said, can we calculate the area of a ellipse? Area of a ellipse. Area of a ellipse, how it can be calculated through three dimensions. It is area of a ellipse is two dimensions. Only x square by a square plus y square by b square equal to 1. Means y equal to 1 minus x square by a square root into b. That is y equal to fx dx. If I have x-axis and over it I have a curve, integrating this curve along x-axis give the area underneath the curve hitting the x-axis. That is the two-dimensional integration. If I have xy plane and there is a surface, integrating the surface along the xy plane will give the volume underneath the surface hitting the xy plane. So if I say y equal to b into a square root of 1 minus x square by a square, if I integrate along dx, where x is minus a to a, would give the area of a ellipse. True. What about if I consider a surface which surface is a flat surface and height is 1? Then integrating for the volume fxy dx dy, where fxy is 1 dx dy. Internally you are calculating the area only. But here if I say y fx dx, then independent component is only one, that is x. If I say fxy dx dy, then independent components are two, x and y. Now y is not dependent upon x, z is dependent upon x and y, that is one constant. So if I have a xy plane, on xy plane I have a origin. Around the origin I have an ellipse, means xy independent there, xy is independent, but the value I take, if I have a z fxy function over x and y, I'll take any value from the xy set, xy set 0 comma 0, 1 comma 1, 1 comma 0 0.5, 0 0.5 comma 0 0.7, 0 0.2 comma 0 0.5, so many value x comma y in from a set I can take. But mind it, if you are taking ellipse on the xy plane, your xy must not go beyond the ellipse. Okay, ellipse include the boundary also. That is the caveat. If that is the case, then we can indeed we can calculate the area of an ellipse with z equal to 1. 1 into dx dy, where the x and y is a is a surface. X and y belongs to a region that is an ellipse. Okay, so one way to solve is x square plus a square plus y square by b square equal to 1, x equal to au and y equal to b, bv. We have talked about it. So if x equal to au, then it becomes u square plus v square equal to 1. This turns up into a circle of radius 1. Now, now the reason I was taking elliptical reason, if I turns up into ub, if I if I turns up into ub, then it becomes a circular region. But what about dx dy? It should be du dv, right? I cannot change directly to du dv. There is the biggest problem. Method of substitution in calculus integral, where we had independent component as x and y and dependent was z. Z was dependent upon x and y, fxy equal to fxy, function over independent component x and y, that was z. Okay, now now xy xy is not dependent upon another independent component, that is u and v. U and v, x and y and z, fxy, function over x and y is z. Now x and y is function over u and v. There is a now independent component came as u and v, and x and y is dependent upon u and v. This is how the relationship is. If z equal to fxy, function over x and y, f braces x comma y braces close, then x equal to guv, y equal to huv. Now uy is the actual independent, now two different plane, uv plane and xy plane. What we are trying to do, dA, dA fxy, dA gives the volume, where A is xy plane, that resolves into dx dy. If I change into u and v, then it should be uv plane, not xy plane. How I can change xy plane to uv plane, where x and y are function over u and v? Okay, so dxy plane equal to dxy plane divided by duv plane into duv plane, as per the simple multiplication. So duv plane is du dv, simple. But what about dxy plane by duv plane? This is called Jacobian, that you need to find out. So whenever, what is dxy by duv? duv is nothing but if is two dimensional, two variable, two dimensional. If I have uv plane and I have a rectangle on the uv plane, this is also a Cartesian only, u axis, v axis. If there is a rectangle here and there is a xy plane and there is a mapping function from uv plane to xy plane, and this rectangle over uv plane maps to some shape on xy plane, if there is a unit change in this rectangle, how much change in area that this shape is seeing, dxy plane by duv plane. So whenever we want to calculate change in area, change in denominator area brings how much change in area in numerator, then we go with the vectorization. Or if I have a vectorization, means if in xy plane, this is xy plane, that is along the origin, and if I have a function, if I take any point on the surface, if I have a surface, any point of the surface, that is x comma y comma z, then there is a position vector, that is xi plus yj plus zk. We are in procedure to calculate rate of change in the area. Okay, so rate of change in the area. So if it is xi plus yj plus zk, position vector of any point on the surface, dp by dx, p vector, p on top of it arrow sign, p vector equal to xi plus yj plus zk, dp by dx would give p vector as I plus dz by dx k, dp by dy would give j plus dz by dy k, means dp by dy has j component, k component, dp by dx has I component, k component, whereas differential dp by dx differential is actually tangent. So if I have a surface, oops, oops, if I have a surface, if I have a surface and surface at any point, if dp by dx is there, dp by dx would move in xz plane because it has I component and k component. dp by dy would move along at any point. If this is the point, if this is the point, then it can hang in this plane. dp by dy would hang in yz plane. At any moment, this can be dp by dx. At any moment, this can be dp by dy, whatever is the area in between. Okay, if this is dp by dx and this is dp by dy, then this is the vector. If I do cross product, it gives me the area. So dp by dx cross dp by dy is nothing but dp by dxy plane. dp by dxy plane. So if whatever the calculation comes, it is if I make one if I draw a rectangle on xy plane, this is xy plane. I draw a rectangle on xy plane and map it to the surface that is on top of it. So mapping of this rectangle on xy plane would map somewhere on the surface, not necessarily a rectangle only. If there is a unit change in xy plane along the rectangle on the surface wherever it had mapped an area region, how many unit of change it brings? dp by dxy plane. Now we want to calculate dxy by duv plane. If that is the case, then if I have dxy by dxy by duv plane, means if I have a UV plane, if I have a rectangle that is mapped into XY plane to some, here I had a rectangle on XY plane, it mapped to some surface area on the surface, fxy equal to fxy, function over x and y. Here function over ub is g, function over ub is h, one is x and one is y. It constitutes another coordinate system, that is xy plane, ub plane, xy plane. dub dxy by duv, if there is one unit change along the rectangle on uv plane, brings how many unit of change if this rectangle is mapped? Consider this xy plane is uv plane and the surface is xy plane. If there is a rectangle on uv plane, if there is a unit change in this rectangle, how many unit of change it brings in xy plane? Okay, if xy plane has p vector, then dp by du cross dp by dv, this would give the dxy by du. Calculate the whatever you get, okay, that you calculate and you get. Okay, so that is the scenario. Now, if I have an ellipse, I have given this example already. We are proceeding on. So if I have an ellipse, then someone can try dp by dx, dp by du, dp by du cross dp by dv. Okay, where p is xi plus yj. There are only two things in xy plane. It is two dimensional. So it at the end it comes as dx by du into dy by dv minus dx by dv into dy by du. If x equal to au and y equal to bv, then it will come as a into b. So dx dy, we were in calculation of area of an ellipse. Now area of an ellipse was a region of an ellipse and 1 into dx dy. Now dx dy converted into a into b du dv. and this region, elliptical region, becomes circular region. X square by a square plus y square by b square equal to 1. X equal to au, y equal to bv. U square plus v square equal to 1. It comes to a circular region. Now AB is a constant. AB I can keep outside, and I have to integrate du dv in a circular region, that is pi r square. R is 1 pi. Pi AB is the area of an ellipse. Okay, can I use this fundamental in two dimensions? I used in three dimensions, two dimensions. Same example we can try in two dimensions. Ellipse y equal to b square root of 1 minus x square by a square. That is b square root of b by a square root of a square minus x square. B by a square root of a square minus x square. That is y. Now fx dx, where single integration of the x minus a to a. Okay, because ellipse minus a to a. Now it is b by a square root of a square minus x square. B by a I can keep outside. Now it is a square minus x square dx. Gave up. I don't know the integration. A square minus x square root. Again, I'll take another coordinate system called u. Here it was x, y, u, v. Now x equal to consider x equal to a cos theta. So we are in theta r plane. Instead of uv plane, I have taken, or someone can say a cos u. So x equal to a cos u. So it becomes a square minus x square. A will come out square root of 1 minus cos square u sin u. So a sin u. A will go out. If a go outside, a would cut down. It will be only b. So sin u, and then what about dx? Dx I have to convert it to du. But since it is single dimensional, we don't need area calculation. We don't need vectorization. Mind it, if I had to calculate dx dy integration to du dv, then since there are two variables come into the picture, it came to area calculation, and area calculation will happen only through vectorization. But here single dimensional vectorization is not required. So what is dx and du? X equal to a cos u, dx equal to a minus sin u du. So x equal to dx equal to du, and Jacobian dx equal to dx by du into du. So dx by du is minus a sin u, that's it, and then du. So Jacobian is minus a sin u. So minus a I can keep outside, so it becomes minus a into b, and then sine square u du. Sine square u integration is u by 2 minus sine 2u by 4. Now if I calculate this, if I calculate the integral, what about the limit? Earlier it was minus a to a. Now if x equal to a cos u, minus a means u equal to pi, and okay, minus a, if it is a, then a by a 1, then it will be 0, pi to 0. Now theta u by 2 minus sine 2u by 4, pi to 0, sine will go away completely, 0 0. U by u will become now minus pi by 2, pi gone, pi 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 gone, and outside here we have a is there, and outside b is there, ab into pi by 2, that is the area. But since we had started with the Cartesian coordinate system, we were in phase of calculating the upper half of the circle. So area of the upper half of the ellipse, so area of the ellipse is ab pi, ab pi by 2 into 2, ab pi, same thing, pi ab. But now we see that Jacobian is everywhere. From dx to du, Jacobian is there. dx dy to dx dy to du dv, Jacobian is there. But there it is matrix. Matrix comes into the picture. What about dx dy dz to du dv dw? Then same matrix will come into the picture. For the two dimension, the matrix is dx by du, dx by, I can take the transpose. So dx by du, dx by dv, and down dy by du, dy by dv. This is the determinant. If I take, then I get the two-dimensional xy plane, uv plane, Jacobian. Three dimension same thing, dx by du, dx by dv, dx by dw. Next row, dx by dx dy by du, dy by dv, dy by dw, dz by du, dz by dv, dz by dw. If you calculate determinant, then dx by du you have to keep outside and calculate the determinant like that. Full you calculate, then that would become 3D, 4D, 5D. You keep adding in the matrix. So this is how it is. What about if I need to calculate the dx dy to dx dy, if I need to, if I need this migration to r theta plane, then what is Jacobian? Then dx by r theta plane, dx by dr, dx by d theta. Another is dy by dr, dy by d theta in a matrix. So it will resolve in dx by dr into dy by d theta minus dx by d theta dy by dr. So Cartesian coordinate to polar coordinate is x equal to r cos theta and y equal to r sin theta. If that is the case, full would resolve in r only. So Jacobian that comes in as r. Why we are not able to convert dx dy directly into du dv? Because there is a function in between. So both, if I draw a rectangle on xy plane, if I draw a rectangle on, oops, if I draw a rectangle on xy plane and draw a rectangle in uv plane, draw a rectangle in x, I mean if I draw a rectangle in xy plane, it would not map as rectangle in xy plane. From uv plane to xy plane, it will map to something different in area, depends upon the function. X equal to r cos theta, x equal to r sin theta. If it is different, the rectangle in uv plane would map differently on xy plane. Okay, if that is the case, then dxy plane by duv plane will have something, because there is a change, it changes differently. So if changes differently, dxy, dx dy, I cannot substitute with du dv. Is it possible to really substitute directly? Yes, it's possible. If x equal to u and y equal to v, or x equal to some scalar into u and y equal to some scalar into v, we took in ellipse. If that is the case, then only some scalar multiplication is required. Dx du equal to some k du dv. Okay, what about if I have dx dy, dx dy dz triple, and there triple there in cylindrical coordinate system? What about dx dy dz changing it to a spherical coordinate system where we have r theta phi, cylindrical coordinate r theta z? Okay, now someone can try. What is x, y, z and cylindrical? Z equal to z, x equal to r cos theta, y equal to r sin theta. What about a spherical coordinate system? X equal to a is the radius, okay, a is the radius, then r sin phi cos theta, y equal to r sin phi sin theta, and z equal to r cos phi. Now try put in a matrix and try dy by dy by dr, dx by dr, dx by d theta, dx by d phi, dy by dr, dy by d theta, dy by d phi. dz by dr, dz by d theta, dz by d phi. Now dx by dr is sine phi cos theta. Dx by d theta is r sine phi minus sine theta. Dx by d phi is r cos phi cos theta. Like that, put in a matrix, triple 3 by 3 matrix, and calculate determinant by determinant, and then at the end you will get the dxyz by dr theta phi Jacobian in spherical coordinate system is r square sine phi. I believe that is the case. We will do it. We are not running away. And for the cylindrical coordinate system, I believe it will be kind of or something. Someone has to calculate. We will do it. Okay, that is the scenario. Someone can take as an assignment what is the volume of a surface? Equation of the surface is 1 by equation of the surface is 1 by and then x minus y whole square, 1 by x minus y whole square, that is z equal to fxy equal to dx dy. The reason along which means if it is xy plane and this is z fxy, on xy plane the reason it confined for the xy would not go beyond it. So if this is xy plane, if this is the xy plane, I cannot take any xy. This must be in a, I am not saying it is circular only, but xy plane must come in a some region, and then there is a function fxy, that is 1 by x minus y whole square, 1 by x minus y whole square dx dy. The reason is x equal to 0, x equal to 0, y equal to 0, x minus y equal to 2, x minus y equal to 4. Famous question. So if this is x axis and this is y axis, this is y axis, this is x axis, this is xy plane. Confined in between x equal to 0 and y equal to 0, that is x axis, x equal to 0 is y axis, and x minus y equal to 2 means this would be like this, x minus y equal to 2 means dy by dx equal to 1. So 45 degree, and it will cut x axis at 2, another will cut x axis at 4, dy by dx equal. There are two parallel line, and x axis and y axis. Whatever the region comes in between, the xy is confined to that region only. Now calculate this volume. Okay, x equal to 0, y equal to 0, x minus y equal to 2, x minus y equal to 4. That is the reason on xy plane. 1 by x minus y whole square dx dy is the integration, or fxy equal to 1 by x minus y whole square. Someone can take u equal to x minus y and v equal to x plus y. If that is the case, then x will be u plus v by 2 and y would be x minus plus y, u equal to x minus y, v equal to x plus y, x equal to u plus v by 2. Okay, if that is the case, then y equal to v minus u by 2. Okay, x minus y. If I sub v minus u by 2, x and y, x equal to u plus v by 2, y equal to v minus u by 2. Now try to calculate the limit. So limit is that x and y belongs to between x axis, y axis, and a line x minus y by 2, x minus y equal to 2, y minus y equal to 2. If I say x equal to 0, if I say x equal to 0, then minus y equal to 2 and plus y equal to 4 if x equal to 0, whereas now u equal to x plus x minus u equal to u equal to x minus y. X is 0, then u equal to minus y. V equal to x plus y, v equal to y, u equal to minus v. One line I converted. So convert this region, whatever the region you are seeing in xy plane, same region draw in UV plane and then decide for the limit. So if it is x equal to 0, then u equal to minus v, y equal to 0. If that is the case, then u equal to x minus y equal to 0 means u equal to x, and v equal to x means u equal to v. Two lines, u equal to minus v or v equal to minus u, v equal to u. Draw the line. Now x minus y equal to 2 and x plus y, x minus y equal to 4. Okay, if that is the case, then how it would map? Okay, if that is x minus y equal to 2, x minus y equal to 2, x minus y equal to u equal to 2, v equal to 4, u equal to 2, u equal to x plus y by 2, and v equal to x equal to x minus y. Here directly x minus y equal to 2. So u equal to x minus y, u equal to 2. Now another is x minus y equal to 4, u equal to 4. Now there are four lines. One is u equal to 2, u equal to 4. Another is v equal to minus u and v equal to u. Now the limit would change where u equal to 2 to 4 and v equal to minus u to u, and 1 by x minus y whole square would change to 1 by u square. Dx dy would convert to dx y by d uv du dv. Jacobian, you convert it, that is dx by du into dy by dv minus dx by dv dy by du. Whatever comes, then into, so easy, right? 1 by u square, and then Jacobian would come in some constant, du dv, limit is minus u to u, that is v, and u is 2 to 4. This is power of method of substitution or parameterization. What is parameterization? X equal to u plus v by 2. This is parameterization. I mean, x equal to f, x equal to guv, y equal to huv, y equal to v minus u by 2, x equal to u plus v by 2. If independent component in our calculation, that was x and y, we make it dependent upon some other independent component u and v, where x can be written as a function with parameter, y can written as a function with parameter. This is parameterization. Okay, so we will proceed on it. Triple integration we have seen. More example will take. More and more example will take. Parameterization, where there are two aspects, Jacobian, non-Jacobian, area vector, and then kind of we did not prove it third way. Jacobian, we proved it in our way. One more way is required. That we will do, and we'll do tons of examples. Because if someone crack this multivariable d area by d area, where both dA are in different coordinate system, it is like a diamond. Any multivariate, any multi-feature that maps in machine learning or artificial intelligence, that person can quickly solve the problem. Otherwise, simple 1 by x minus y whole square dx dy and integration over a region, that is x equal to 0, y equal to 0, x minus y equal to 2, x minus y equal to 4, it becomes impossible to do. Now it becomes possible. So this is powerful, very powerful, and very powerful we will see.